Hello there, and welcome to Point Level High Robotics.
On the robot, we use physics and mathematics, computer science. For instance, on the wheels, we have a gear ratio, which means that the motor doesn't directly drive the wheel. We have a gearing that's meshed into each other, and then that drives the wheel indirectly. So we use mathematics to figure out, if the motor's turning at a certain rate, given this gear ratio, how fast is the wheel going to turn. We also use mathematics in the most elementary part of the robot, which is the computer science involved in making all the operations move. In order for the robot to move autonomously, which means move by itself without any human operation, we have to use mathematics and matrices, trigonometry, to incorporate various sensor data and let the robot know, where it is on the field and how to react accordingly. With mathematics and computer science, then, in that combination, we can make a robot do complicated tasks on its own. And then when it's time for the teleop phase, which is the driver-controlled phase where we actually control it with a Game Boy controller, we can tell it to do certain things that are even more complex.
For our robot, we had to use many forms of math. Especially for these tubes, you can see how they're cylindrical cones. We had to figure out the exact diameter and the area so we could cut the right sizes, so each one would telescope out like a lightsaber. Including that, you can see how we do sometimes math on aluminum. And it's permanently there and you're always going to have it. On top of that, we're using two different types of motors. These two motors have different types of gearing. The front motors are 52-to-1, the back motors are 40-to-1. So we have to figure out the right power systems, or power settings, so that they run at the same speed, so you're not pushing against one motor while pulling against the other ones.